of unit and measurement. These two are two different things. Here, first of all, what is unit? Actually, unit is a value or quantity in terms of which other quantities can be measured or expressed. Here, in any physical quantity, physical quantity is made meaningful by adding their units. Just like suppose we buy anything, then in kilogram, sometimes time is measured in second, mass in kilogram, time in second. Similarly, density is expressed in kilogram per kg per cubic meter. Speed is expressed in meter per second or centimeter per second. They are the units. And the process of comparison of unknown quantity with any known quantity or standard quantity, that process is called measurement. Yeah. Then all the physical quantities must have their units. Just like suppose we express density. Then what is density? As you know, density equal to mass by volume. Mass by volume. Then adding their units, mass is expressed in kilogram, volume, then cubic meter in SI system. So we can write here kg per cubic meter. This is the SI unit of density. Likewise, we express acceleration. Then acceleration is equal to change in velocity by time taken. A equal to v minus u by t. And here, unit of velocity is here in SI. Unit of acceleration, we know that A equal to v minus u by t. Here, v represents final velocity, u represents initial velocity, and t represents time taken by the body to cover the distance. Then here, v, unit of velocity is meter per second, and unit of initial velocity, this is also meter per second, and for time, that is second. So we write here meter per second by second. This means like meter per square second, or in this way meter per meter second minus 2. In this way also we can write unit of acceleration. This is the unit of SI unit of acceleration. In the same way, for writing CGS system, centimeter second minus second per square second. This is the CGS unit of acceleration. In this way, if unit is added to any physical quantity, then that physical quantity becomes meaningful. If we do not add any, suppose you go to buy sugar, then you must say, please give me 2 kilograms of sugar, 2 grams of sugar. If you do not add any unit here, if you do not express that physical quantity in any unit, then that will not be meaningful. And here, one thing must be noted that while writing any unit, it should not be followed by any full stop. Okay? Just like if you write here kg, this is correct way, and if you write kg in this with dot, this is wrong way of representation of any unit. And here, how to find the unit of any physical quantity? To write how you find the unit of any physical quantity? Just like suppose for this we know that unit of mass kilogram. This is the physical quantity, and here is units. It's MKS. Mass, then we write kilogram. Time, then time in second. Length, breadth, height, depth, these all are expressed in meter. Similarly, speed, distance traveled by time taken. Distance traveled by time taken. So, distance is expressed in meter and time in second. Therefore, we can write meter per second. Velocity, speed and velocity, these two have same unit. Velocity, then distance traveled in a straight line. Or we can write displacement, also can be written displacement by time taken. Displacement is expressed in meter and time in second. So we can write here meter per second. Force, or we can write acceleration first. Acceleration, as I have already said here, A equal to V minus U by T, then meter per square second, or we can write here meter per second minus 2. Similarly, force, F equal to mass into acceleration. Mass is multiplied by acceleration, then it gives the magnitude of force. So, while writing experiment, mass is expressed in kilogram and acceleration is expressed in meter per square second. Therefore, we can write kg meter second minus 2. Or we can write Newton. Yeah. Similarly, while writing the unit of momentum P is equal to mass into velocity. Mass into velocity. Here, mass is expressed in kilogram and velocity is expressed in meter per second. So we can write kg meter second minus 1. This is in MKS. MKS unit, and we can write Newton into second also in SI unit. Similarly, impulse equal to force into time. Force into time. If force is multiplied by time, it gives impulse. So here force is expressed in amperes, kg meter per square second into time second. This gives kg meter per second. This is the unit of impulse. Remember these 2 points, that impulse and momentum, these two have the same units. Here, by the same way, to write the unit of impulse, then velocity, acceleration. We have studied about acceleration, velocity, impulse. Here, area. Suppose we are expressing our unit of area. Then what is area? It is a multiplication of two dimensions, just like length and breadth. So area equal to L into B. We can write. Then length is expressed in meter. Breadth is also expressed in meter. This gives meter or square meter. We say square meter area. Then volume. Like the unit of volume, V equal to L into B into H. So its unit will be cubic meter, area, volume, density equal to mass by volume. This unit is kg by kg per cubic meter. We can write kg per cubic meter. In this way, we can derive the unit of some of the physical quantities. Here, there is a relation between Newton and Dyne. Relation between Newton and Dyne. We know that F equal to M into A. We know that F equal to M into A. While writing this unit, force is expressed in Newton, mass is expressed in kg, and acceleration is expressed in meter per square second. So, 1 Newton equal to 1 kg into 1 meter per square second. Expressing that into CGS system, 1 kg equal to 1000 gram. 1 kg equal to 1000 gram. And here 1 meter equal to 100 centimeter per square second. So we can write here 10 to the power 5 gram centimeter per square second, and this is equal to 10 power 5 and done. 10 power 5 done. So we can write 1 Newton equal to 10 to the power 5 times. In this way, we can express Newton into dyne by this way. Suppose 5 Newton, then 5 into 10 power 5 dyne. The same way, suppose 20 Newton, this means 20 into 10 power 5 dynes. And in scientific notation, we can write 2 into 10 power 6 dynes. Now, here we should understand that the unit is divided into two types. Unit is classified into two types: fundamental unit and derived unit. Fundamental unit and other is derived unit. Here, fundamental unit means the unit of the fundamental quantities. Unit of fundamental quantities are known as fundamental unit. Similarly, unit of derived quantities are known as derived unit. Fundamental unit, just like length, mass, time, temperature, luminous intensity, current, amount of substance, they are considered as fundamental units. And unit of derived quantities are known as derived unit. Derived unit, just like those units which depend upon the fundamental units. Fundamental units, just like while expressing our derived unit, just like area, velocity, acceleration, force, these are known as derived units. Power is also derived unit. Here, some fundamental units. Fundamental units. Some fundamental units, understand here quantities are there. Fundamental quantities, just like length, mass, time, temperature, luminous intensity, electric current, and amount of substance, they are considered as fundamental quantities. And here, their units, length is expressed in meter. So in symbol we write m, mass, kilogram, kg, time, second, we write here as in symbol. Temperature is expressed in Kelvin in SI system, and here K for symbol. Luminous intensity, candela, CD. Current is expressed in ampere, so we write capital A here in symbol, and the amount of substance, moles, MOL in short. They are fundamental quantities and their symbols, units and their symbol. Now, derived quantities depend upon these fundamental quantities. Just like if you will be asked, how can you show that unit of power is derived unit? Unit of power is derived unit. Why it is derived unit? Because as we know that power equal to work done by time taken. Work done by time taken. Here work. Why writing here units? Work. Unit of work is in simple form we write for work W equal to F into S by time T. So while writing the units, force kg meter per square second into displacement meter by time second kg meter square meter second minus 2 divided by second. So kg meter square meter into second minus 3. So here we can see that unit of power depend upon the three fundamental units: kilogram, meter, and second. Therefore, unit of power is the derived units. In the same way, you may be asked, unit of force is the derived unit. Why? Unit of force is derived unit. Unit of force is derived unit. How can we say that unit of force is a derived unit? Just like find the unit of force, just like force equal to, as you know, mass into acceleration. Then mass, unit of mass is kilogram in SI system, and for acceleration, unit of acceleration is meter per square second. So we can write kg meter per square second in SI system, MKS system. Here we see that the unit of force depends upon three fundamental units: kilogram, meter, and second. Kilogram, meter, and second. Therefore, we can say that the unit of force is a derived unit. In the same way, we can write unit of pressure. Unit of pressure is a derived unit. Derived unit. How? Pressure equal to force by area. Force by area. While writing derivatives, force mass into acceleration, as you know, force equal to mass into acceleration, area equal to area, then we can write here area A, mass. Using their fundamental units, mass, kilogram, area, square meter by mass, acceleration. This is here the acceleration of the area, force, mass into acceleration. Mass into acceleration. And here area. So we can write for mass M, acceleration A, area capital A. Using the fundamental units of these physical quantities, mass is expressed in kilogram, this is acceleration, so meter per square second, and area, it is expressed in square meter. So we can write kg meter by meter square into second square, meter cancels, so kg meter minus 1 second minus 2, or we can write here. This shows that unit of pressure depends upon three fundamental units: kilogram, meter, and second. Therefore, it is also a derived unit. So, in this way, we can find whether what type of physical quantities are involved in the given physical quantity, what type of units are depending, what type of units are involved in the unit of pressure, force, acceleration in this topic. And now to express MKS system into CGS system or conversion. In this topic, we have conversion. Just like kilogram into gram. Kilogram into gram. Kilogram is the SI system, SI unit, gram is CGS unit. We know that 1000 gram equal to 1 kg. This point should be remembered. Just like suppose we have to express 2 kg. This means simply 2000 grams. 2.5 kg. It means 2.5 into 1000 gram. 1000, or we can write simply 10 power 3 gram. In this way, kilogram can be converted into gram, gram can be converted into kilogram. Just like suppose 20 gram, convert 20 gram into kg, kilogram. Here we know that 1 gram equal to 1 by 1000 kg. Therefore, 20 gram equal to 20 by 1000. 20 by 1000 kilogram. 0, 0 cancels. 2 by 10 power 2 can be written kg. This is equal to 2 into 10 power minus 2 kilogram. Similarly, to convert kilometer per hour into meter per second, convert kilometer per hour into meter per second. Just like 1 kilometer equal to 1000 meters and 1 hour. 1 hour equal to 60 minutes and this is equal to 60 into 60 seconds equal to 3600 seconds. By using these two informations, we can convert kilometer per hour into meter per second. This is the unit of the speed or velocity, just like 20 kilometer per hour. For 20 kilometer per hour is to be converted, then 20 into 1000. This is in meter. Now here is hour. To convert hour into second, we should divide by 60 first. On dividing by 60, changes into this changes into first of all kilometer per hour. No, here this is converted into meter. Now first time if we divide by 60, it's converted into minute, and again we divide by 60, it converted into second. This way 1 0 2 0 cancels, 2 5 za, 2 3 za, 2 3 za, 2 10 za. This is equal to 50 by 9 meter per second. This much meter per second. Here, to convert kilometer per hour into meter per second, just like for example, we convert 90 kilometer per hour into meter per second, then 90 into 1000. When we multiply it by 1000, it converts into meter. And now, if we divide by 60, once it gets converted into minute, and again if we divide by 60, this gets converted into second. And this on calculation gives 25 meter per second. Or in the same way, if we convert 1 kilometer per hour into meter per second, same process is to be followed. 1 into 1000 by 60 into 60. This whole calculation is now converted into meter per second. And on solving, it comes 5 by 80 meter per second. So we can say that 1 kilometer per hour equal to 5 by 80 meter per second. Similarly, 90 kilometer per hour equal to 90 into 5 by 80 meter per second. That is equal to 25 meter per second. It means that if kilometer per hour, if any value is given in kilometer per hour and we multiply that value by 5 by 80, it gets converted to meter per second. This is also one of the simplest way of converting kilometer per hour into meter per second. But the same way, suppose we have to convert density, unit of density into SI system. That's like 2.5 gram per square meter is given, and you have to convert it into SI system. Then 2.5 divided by 1000, this gets converted into kilogram, and here cubic centimeter given. This can be split into 3 factors. Say 1 centimeter into 1 centimeter into 1 centimeter, and 2.5 by 1000. This is in kilogram by 1 by 1000, 1 by 100. Meter into 1 by 100, meter into 1 by 100 meter. This is equal to 2.5 into 10 power minus 3. Here 10 we can express 1000 into, here is divided by 1000, so we can write 10 to the power minus 3. This is in kilogram. and divide by 1 by 10 power 6. This is in cubic meters. So 2.5 into 10 power minus 3 into 10 power 6. This 10 power 6 gets multiplied here, and it is equal to 2.5 into 10 power 3 kg per cubic meter. 2.5 gram per cubic centimeter equal to, we can write 2.5 gram per cubic centimeter equal to 2.5 into 10 power 3 kg per cubic meter. In the same way, we can write 1 gram per cubic centimeter. This is equal to 1000 kg per cubic meter. This point also should be remembered. Now, here in this topic, we express any power into powers of 10, any big numbers or small numbers in terms of powers of 10. If we express very big numbers and very small numbers in terms of power of 10, it saves our time and space as well. Therefore, here how do we express in terms of powers of 10? Powers of 10. Just like, suppose 10 is given. It means that we are like 10 to the power 1. If written 100, it means that 10 to the power 2. Why do I write 10 power 2? This is 10 into 10. 2 times 10. 10 into 10. Therefore, we can write 10 to the power 2. Suppose 3 0 are given in 1. This means that 10 into 10 into 10. This is equal to 10 power 1, 1, 1. So we can write 10 power 3. By the same way, 25, 0, 0, 0 given. This is equal to, numbers are 2, 5. 2, 5 into, how many 0 are given? 3, 0. Therefore, we can write 10 power 3. 25 into 1, 2, 3. So 3 0 are given, therefore we can write 10 power 3. And while expressing in terms of powers of 10, here 25 is given before this sign of multiplication sign. Therefore, we can write in this way: 2.5 into 10 power 4. 2.5 into 10 power 4. This is the value of these 25,000 small numbers in terms of powers of 10. Here, one point to be noted that this number, before the sign of multiplication, should be smaller than 10. Just like we have to express 0, 0, 0, 0, 0, 0, 0, 0, 0 in this very big number. How to write? Just like 45 is given in number, then 45 and into sign. Then after that, we count the number, total number of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 0 are given, so we can write 10 to the power 9. And this can be represented by 4.5 into 10 power 10. This is your answer. Suppose example. Next example. Example number 3rd. Suppose you have to express 3, 2, 5, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. In terms of powers of 10, here we separate them by comma. Then how many 0 are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here number is 3 to 5. So 3 to 5, first of all, we write this number 3 to 5. And now give the sign of multiplication and then count the number of 0. How many 0 are there? 2, 3, 4, 5, 6, 7, 8, 9, 10. So we give here 10 to the power 10. And to express this number, we can write 3.25 into 10 power 2 for this much only. and then the remaining number is 10 power 10. So you can write 3.25 into 10 power 10 plus 2. According to law of indices, write here 10 plus 2. That is equal to 10 power 12. This is the simplest form or in terms of powers of 10. Yeah. In the same way, suppose 0.1 given, 0.1, and we have to express in terms of powers of 10. Then here 0.1, this 1 divided by. For this decimal, we write here 1, and how many numbers are here? There is only one number, 1 only. So we can write for this one, we write here 0, and this is equal to 10 to the power minus 1. According to law of indices, we follow here the same law, 10 to the power minus 1. Suppose 0.02 given, and you have to express in terms of powers of 10, then the number is 2. So we write here 2 divided by. For this decimal, we write 1, and total number 0 and 2. Two numbers are here, so we write 20 after 1. 20. Now 2 divided by 10 power 2. This can be written 2 into 10 power minus 2. Here, suppose we have to convert this number, we have to express this number in terms of powers of 10 like the previous way. Here we express the number 2, 3, 4. First we write 2, 3, 4. This number divide, and for decimal we write 1 and count the total number. 1, 2, 3, 4, 5, 6, 7, 8, 9. This also should be counted. 9. Total number is 10 power. We are writing 10 power 9. So 2, 3, 4 into 10 power minus 9. And for this 2.34 into 100. If we write for this number 234 into 100, this becomes 2.34 into 10 power 2. And here 10 power minus 9, then it becomes 2.34 into 10 power minus 9 plus 2. This is equal to minus 7. In this way, we can express very small numbers or very big numbers in terms of powers of 10. Now, at the end of this lesson, we should know that here some of the homeworks are given for this topic, just like convert 60 kilometer per hour into meter per second. One number, two number. Convert 3.25 gram per cubic centimeter into kg per cubic meter. Gram per cubic centimeter into kg per cubic meter. Or we can write in SI system. Similarly, three number. Convert 45 milligram into quintal. 1 quintal, there is means 1 quintal equal to 100 kilogram. Now, express in terms of powers of 10. Powers of 10. A 0.0000238, B 2560000, C 0.000000001, 2. Unit of density is a derived unit. How?